In the heart of the Cold War, the United States Air Force envisioned a bomber that could fly faster and higher than anything before it, a machine so advanced it could outrun enemy fighters and missiles. The world was locked in a tense standoff, and the skies became a new frontier for technological supremacy. Every advancement in aviation was a statement of power, and the need for innovation was urgent. The stakes were nothing less than national survival, and the Air Force was determined to stay ahead of any threat. This dream became the North American XB-70 Valkyrie, a symbol of technological ambition and the relentless pursuit of progress. With its sleek lines and futuristic design, the Valkyrie captured the imagination of engineers and the public alike. It was more than just an aircraft, it was a bold vision of what the future of flight could be. The Valkyrie story began in the 1950s, when subsonic bombers like the B-52 were becoming vulnerable to Soviet air defenses. Radar and missile technology were advancing rapidly, making traditional bombers increasingly obsolete. The Air Force realized that a new approach was needed to maintain a strategic edge. The Air Force demanded a revolutionary solution. A bomber that could penetrate deep into enemy territory at unimaginable speeds and altitudes. They wanted an aircraft that could fly so high and so fast that it would be nearly untouchable, able to deliver its payload and return home safely. North American Aviation answered with a radical design, a massive delta-wing giant, painted brilliant white to reflect the heat of high-speed flight. Its unique shape was not just for show, it was engineered to handle the extreme conditions of supersonic travel, pushing the boundaries of what was thought possible. Powered by 6 jet engines, the Valkyrie could exceed Mach 3, representing a quantum leap in bomber technology. Its engines roared with unprecedented power, propelling the aircraft to the edge of space and rewriting the rules of aerial warfare. When the first XB-70 rolled out in Palmdale, California, its spaceship-like appearance and immense scale stunned onlookers. Crowds gathered to witness the unveiling of a machine that looked as if it had arrived from another world, a testament to American innovation and daring. The project pushed the limits of materials, manufacturing and aerodynamics, embodying the era's can-do spirit. Engineers and technicians worked tirelessly, overcoming countless challenges to bring the Valkyrie to life, driven by a shared sense of purpose and pride. The Valkyrie stood as a testament to American ingenuity, a bold leap into the unknown. Even today, its legacy endures as a symbol of what can be achieved when vision, determination, and technology come together in pursuit of the extraordinary. The XB-70's most astonishing feature was its speed, Mach 3, a velocity that pushed the boundaries of what was thought possible for a manned aircraft in the 1960s. This was a time when supersonic flight was still in its infancy, and the Valkyrie soared far beyond the capabilities of its contemporaries. That's about 2,000 miles per hour, faster than a rifle bullet, and nearly 3 times the speed of sound. At such speeds, the world below blurred into a streak, and the XB-70 became a symbol of American technological ambition. At this velocity, it could cross the entire United States in just 90 minutes, outpacing any Soviet interceptor or missile defense system of the era. The Valkyrie was designed to be untouchable, a ghost streaking across the sky. 6 massive General Electric turbojet engines, each a marvel of engineering, used high-temperature fuel and powerful afterburners to generate the extraordinary thrust needed for such performance. The roar of these engines was legendary, echoing for miles and announcing the Valkyrie's raw power and presence long before it was seen. A key innovation was compression lift. The aircraft's unique underside trapped shockwaves at supersonic speeds, creating a cushion of high-pressure air beneath the wings. This ingenious design made the XB-70 more efficient at high speeds, reducing drag and increasing lift. This allowed the Valkyrie to sustain Mach 3 over long distances, a feat that influenced the design of future supersonic and hypersonic aircraft for decades to come. But flying this fast created immense heat, over 600 degrees Fahrenheit on the skin, hot enough to weaken or melt conventional materials. The Valkyrie faced a constant battle against the searing temperatures of high-speed flight. Advanced materials like stainless steel honeycomb panels and titanium, along with the aircraft's distinctive white paint, helped manage and reflect the heat, protecting the structure from damage. Even the fuel played a dual role, doubling as a coolant by circulating through the airframe before reaching the engines, absorbing and carrying away excess heat. Every detail, from the smallest bolt to the largest wing panel, was meticulously engineered to conquer the extreme environment of Mach 3 flight, making the XB-70 a true marvel of its time. The Valkyrie soared at over 70,000 feet, on the edge of space, where the sky fades from blue to black and the curvature of the Earth becomes visible. At these extreme altitudes, the aircraft operated in a realm few others could reach, pushing the boundaries of what was possible for manned flight. It flew above most missiles and interceptors, out of reach of conventional threats, making it nearly untouchable by enemy defenses of its time. Its massive delta wing generated lift in the thin, frigid air, allowing the Valkyrie to maintain stability and control even as the atmosphere thinned dramatically. The drooping wingtips, a unique innovation, pivoted down at supersonic speeds, improving both stability and aerodynamic efficiency, and helping to reduce drag during high-speed flight. The two-man crew sat in a pressurized, air-conditioned capsule, shielded from the harsh, near-space environment outside. In emergencies, this capsule could eject as a self-contained escape pod, offering a rare level of safety for such a high-performance aircraft. Operating at such heights, the Valkyrie flew far above commercial airliners and even the most severe weather, cruising in a world of its own. It rivaled legendary spy planes like the U-2, but with far greater speed, size, and payload, making it a true marvel of Cold War engineering. This high-altitude capability not only enhanced bombing accuracy, but also expanded reconnaissance potential, giving the Valkyrie a strategic edge. From these heights, the Valkyrie could survey vast areas below, gathering intelligence or delivering its payload with unprecedented precision. The aircraft's advanced systems were meticulously designed for survival and performance in an environment few others could endure, combining cutting-edge avionics with robust engineering. The dream of a bomber ruling the stratosphere became reality with the XB-70, a symbol of technological ambition and daring. Its unique features set new standards for high-altitude flight, influencing future generations of aircraft design. The Valkyrie's dominance at altitude was unmatched in its era, a testament to the vision and ingenuity of its creators. It redefined what was possible for strategic bombers, leaving a legacy that still inspires awe in aviation enthusiasts today. The XB-70 was built for intercontinental range, over 6,900 miles unrefueled, allowing it to strike deep into enemy territory and return home. Its massive fuel capacity and efficient supersonic cruise made global reach possible. A typical mission: takeoff, accelerate to Mach 3, climb to 70,000 feet, strike, and return before enemy defenses could react. The Valkyrie was designed as the ultimate first strike and retaliatory weapon, ensuring no target was safe. However, the rise of intercontinental ballistic missiles and improved Soviet air defenses challenged the bomber's role. The Valkyrie's strategic mission was cancelled, but its design set a benchmark for long-range bombers. It demonstrated the peak of what was possible in 20th century aviation. The legacy of its range and speed endures. The Valkyrie's primary mission was to deliver nuclear weapons with devastating effectiveness. Its large internal bomb bay could carry up to 14 nuclear bombs, released at Mach 3 with a sophisticated mechanism. The system was engineered for flawless operation at extreme speeds and altitudes. The Valkyrie was also considered for reconnaissance, swapping bombs for cameras and sensors to gather intelligence at unprecedented speed and altitude. Its existence embodied the Cold War strategy of deterrence, a bomber so unstoppable it would prevent any first strike. Though the program was cancelled before production, the prototype symbolized the lengths nations would go for security. The Valkyrie's deterrent power was as much psychological as technological. The XB-70 was a technological marvel, pioneering new materials and manufacturing techniques for Mach 3 flight. Titanium and stainless steel honeycomb panels, welded with innovative methods, formed its strong, lightweight structure. Its advanced electronic flight control system, an early fly-by-wire, coordinated the drooping wingtips, canards, and twin tails for stability. Compared to the B-52 and Soviet bombers, the Valkyrie was in a league of its own, leapfrogging an entire generation of design. NASA and the Air Force used the prototypes as flying laboratories, gathering invaluable data on high-speed flight, propulsion, and materials. The research laid the foundation for future aerospace programs. The Valkyrie was more than a weapon. It was a national asset for scientific discovery. Its innovations shaped the future of aviation, The XB-70's legacy is found in every supersonic aircraft that followed. Though the Valkyrie never entered service, its influence was profound. Its research directly shaped the Lockheed SR-71 Blackbird, which faced similar challenges of Mach 3 flight. The XB-70's lessons in high-temperature materials and engine design helped make the SR-71 the fastest, air-breathing aircraft ever. The Valkyrie also informed America's supersonic transport program and even the Concorde, advancing the science of large supersonic airliners. The Soviet MiG-25 Foxbat was developed in response to the Valkyrie, showing its impact on both sides of the Iron Curtain. The program highlighted the economic and political realities of ambitious aerospace projects. Costs were immense, and strategic needs shifted. The Valkyrie's story is one of technological triumph and practical limits. It became one of history's most important research aircraft. The XB-70 paved the way for a new generation of supersonic giants. Its legacy endures in aviation innovation worldwide. Only 2 XB-70s were built, Air Vehicle 1 and 2, serving as testbeds for high-speed flight. In 1966, tragedy struck when AV-2 collided with a smaller jet during a photo shoot, resulting in the loss of both aircraft and 2 pilots. The accident was a devastating blow, but the surviving Valkyrie continued research missions for NASA. As strategic needs faded and costs soared, the program wound down. In 1969, the last Valkyrie made its final flight to the National Museum of the United States Air Force. The era of the Great White Bomber ended, but its impact was permanent. The XB-70's data and innovations lived on in future projects. Its story is a reminder of the risks and rewards of pushing technological boundaries. The Valkyrie's legacy is one of both triumph and tragedy. It remains a symbol of human ambition and the quest for flight. The last XB-70, Air Vehicle 1, is on display at the National Museum of the United States Air Force in Ohio. Standing beneath its massive delta wing, visitors are awed by its futuristic design and scale. The exhibit tells the complete story, from Cold War conception to final research flights. Informative displays and artifacts bring the Valkyrie's history to life. The aircraft's presence is a tribute to the visionaries who built and flew it. The XB-70 remains one of the most beautiful and ambitious aircraft ever created. Visiting the Valkyrie is a powerful reminder of our drive to push boundaries. It continues to inspire awe and wonder in all who see it.